Hey, hi. Uh, so let's start with our Docker fundamental course. And this course is focusing on complete end-to-end Docker from the in and out. Okay. So you'll get to know what all kind of real-time practice we do at the industry level or we do at the companies and organizations. So everything I'll be going to cover this course, and it is a very special course that you'll get a full clarity on the Docker. So don't miss out this, guys. Okay, so let's get started. So here we are going to start from the very basic to very advanced. So where we do deployments, how the real-time industries are doing. First of all, let's understand what is a Docker. First thing, okay. And before that, let's understand what is the problems we have. Why the Docker came into the picture. Before that, we'll understand the problems. What problems we have with the traditional infrastructure. So why will going with the traditional approach? Installation, configuration are going to take a lot of time, need a much maintenance also. Okay, we need to install, giving the time and doing the configurations on every single server in every single environment. Like if you focus on the first point, we have environment like dev, QA, staging, and production. So we have to focus on in each environment will be how to keep a service. For that server I need to do installations and configurations and all those things, right? And that server may into needed few things like compatibility and dependency. We need to keep tracking of patches, right? So there will be patch management we need to do, config management we need to do, dependencies installations we need to do. Okay, so these kind of compatibility dependencies we need to also resolve on the servers in each server and in each environment. And sometimes inconsistence across environment, like it is very hard to track the changes what's happened at the environments. Okay, if it is a production, yes, we are into the hell. And operational and support, yes, we need to maintain the resource handle. Okay, we need to handle the resource operational things every day, each day. So for that we need to utilize the tools, third party tools. We need to configure few jobs to get the health check of the servers. And if it is went into a problem, we need to come up with the solution immediately. If not, it is going to affect the time, uh, the development time and the operational time in the organization. Okay, so particularly when developer environments, when new developer joins the team, and it take a lot of time to provision his development environment for his doing testing or development things. Okay, so it is going to take a lot of time for an engineer. So these are the traditional infrastructure problems. Okay, so that means, for example, if I'm having an environment, dev environment, and if I'm having a QA environment, so in each environment we are not going to keep one server, so we have to keep multiple servers. Okay, so let's say I have a one server, I have another server, and I have another server, three servers here. Okay, so in real time it's not about the three servers, it is going to be 10, 15, 50 also, 50 servers also. Okay, it is going to be a 50 servers also. So that many servers will be having into a cluster, and here also I will be having the same kind of service. Okay, so let's understand something like a developer wants to do some testing on the different environments. Like, so take it as an example of a browsers itself to make you understand more clear. I'm going to call this box as for the Chrome browser. Okay, and this browser for the Edge, and this browser for the Firefox. Okay, now the application is ready, and this application need to be tested on the three browsers. Is that working perfectly or not, or whatever the developer is enabling cookies or whatever. So you want to do some testing things, the does this application is working perfectly on the three or not. Okay, so for that we have to set up an environment. Okay, so setting up an environment like this application should be on the Chrome server, and also it should be on the Edge server, and it should be on the Firefox server. So how many servers we are utilizing here? Three servers. For three servers, I need to configure hardware things, right? Okay, so memory and CPU, we need to take it. And also here I need to install an operating system. Again, this is a licensed operating system I need to go, right? Here also I need to go licensed operating system, and maintaining this operating system, and as well as this configurations, this server, and doing deployment here. Okay, doing deployment here. And so developer is continuously deploying an application here. So let's say it is right now 2 GB server, and this application is running and it occupied 1.5, and developer is continuously deploying and he want to do a testing, or tester is completely doing a testing here continuously want to deployment. So in the such cases, I need a more space, right? Again, 1.5 GB is not going to be enough. Again, we have to add a disk, we have to go for it, extra configurations. So this is going to be a biggest problem to an engineer, that so setting up these many configurations and maintaining this service. So that's what the traditional infrastructure we used to have. For each and everything, we have to set up a server separately. We need to maintain the server separately in each environment. Not about this, in each environment. If I want the same kind of thing here, yes, I have to maintain the same here as well. This is, let's say, dev environment, and this is, let's say, QA environment, and let's say it is staging environment. Okay, so like this. So this is the problem. So to avoiding this kind of problems, there's a new technology came called virtualization. Okay, so what is a virtualization again? So when we talk about the virtualization is two types. First thing, or hypervisor, you can say. Okay, hypervisor and virtualization both. Okay, so now before this, you can just assume like your VMware itself only, that is a virtualization. But let's understand something. Virtualization is having two types. One is hypervisor 1 and hypervisor 2. So when I talk about the type 1 hypervisor, okay, so type 1 hypervisor is nothing but your installed hardware directly. It is hardware. Okay, hardware is nothing but bare metal server, we call bare metal server, we call. Okay, so this is nothing but directly the hardware. The hardware means we are, while the creating the bare metal server, right? So it's having the device, the physical device, a run physical device. So that is the type 1. Okay. So example, it includes VMware, and it includes ESXi, it includes hypervisor, Microsoft hypervisor, Hyper-V, and it includes KVM. Okay, so kernel based virtual machine, and also it includes X. Okay, so these are the comes under type 1, which are nothing but a direct hardware bare metal servers. So this is going to be directly installed on the hardware, the direct bare metal server. And what about the type 2 then? Okay, what about the type 2? So type 2 also, let me, yeah, so type 2 also, it is going to run on your host operating system. Okay, so type 2 hypervisors are running on the application with our host operating system. So for example I will say, so type 2 hypervisors are commonly used desktop application, commonly used desktop applications. Okay, so which is nothing but it is run on top of host OS, running top of host OS. Example, your VMware workstation application, right? Yeah. And Oracle and VirtualBox, and we have this one parallel desktop. So these are comes under type 2. So which these are applications, right, which is going to run on the top of the base operating system, and it is going to creating you a logical VMs you can create. Again, it's giving you a one more option to the install and do your testing and create the environments. So with this, actually it is very easy to create the environment and for development testing and this one, and it is flexible also. Okay, so it's best on the desktop computers. Okay, so this is the type 1 and type 2. So type 1 and type 2 means I have a server, I have a server. So this server will be having bare metal configurations, nothing but compute engine, nothing but compute engine. So this compute engine is nothing but which we are giving the configurations about CPU, okay, and memory. CPU and memory. So these are the nothing but refers to the bare metal, the hardware thing. Okay, the hardware of the server. And top of it, on this compute, on top of this, we are going to run our operating system. Okay, so we are going to run our operating system. So this is operating system and this is the compute service. Compute. And here it is operating system. The operating system can be anything. Okay, and top of this, so this is referred to the one hypervisor one. Okay, so this is referred to the hypervisor one. And top of this, we are going to run again an application like VMware Workstation or Oracle, Oracle VirtualBox or Parallel Desktop. Okay, so these are all going to be your type 2 hypervisors. Okay, so on top of this, what you do, you again going to run an applications. Okay, so parallel desktop kind of things, applications. I'll take with this. Okay, so here it is going to be on top of our host operating system, and the down host operating system already running right here. On top of this host operating system, this application we are going to run, for example, VMware Workstation. VMware Workstation. So when you do this, on top of this, again we have to go and create the logical. For example, so this server is having a CPU memory 8 GB or 20 GB or 15 GB, and this VMware also going to utilize, my operating system also going to utilize the same space, and this VMware workstation also going to utilize from my same space. Okay, from same resource configurations. And again, on top of this, we can run our environment, isolated environments. Okay, so I'm going to take another color for it, or this color would be the good. Okay, so these are the environments. So in these environments, again we have to go with the operating system. Again, we have to go with the operating system. Operating system. On top of it, you can run your application. Okay. On top of this, we can run our application here, like this. So this is hyper 2. Okay. So this is type 1 and the second one is type 2. This is type 2. So on top of we are responsible to even maintain this operating system on the VMware workstation here. So it is also going to utilize my the server configurations only. It is also going to utilize my server configurations only. Okay. So it is in the single server, we are doing in the single server and two environment setups. But in the previous case of traditional, we have to maintain the separate servers. But here, the single server, we are doing setting up two environments. Let's say this is a dev environment and this is a QA environment. Okay, so here I can go with the Chrome browser or here I can go with the Edge browser like this. So doing testing in two different servers with the two different operating systems. This operating system can be a Windows, this operating system can be a Linux. Okay, so whatever, and it is not related to this one also because this operating system can be anything. Once you install VMware Workstation, you can run any of the operating system in this logical VMs. Okay, so in the single server, we are creating two or more environments by enabling the virtualization. Okay, this is what the virtualization means. And here we have a disadvantage. What it is, that means the network configuration. Here on from the VMware workstation to our host server, so configuration should be proper and our server enough able to provide the capacity to run this virtual servers or virtual VMs in it. Okay, and the installations of this your operating system inside this should be perfect. So if this is also want one CPU or two CPU and you are running a big application, yes, you have to increase your server configurations also. So this is again an headache. It is not lightweighted. For example, I have a one more server and I want to install this application here which is running here already. So moving of this is not possible that easy. Okay, so moving of this application from the one server to another server in the virtualization concept is not that easy much. Okay, so there's a disadvantage and it is not having the you have to maintain all this capacity like server memory CPU and all distributions also network also somewhat complexity you have to face. So that is the virtualization. Okay, now let's come to the Docker point of view. So this much is like this much we are handling, right? So this is what our responsibility to maintain this at the organization to make it successful, right? So not only single server we are maintaining, we have to maintain like plenty of the servers in one environment. Like one environment can be a 30, 40, 50, 100 servers also. Yes, I'm right. An environment can be 100 servers also possible. So in the organizations, in few organizations, okay, there are 100 plus servers are there. Maintaining this much is not easy. Okay, and maintaining, so sir, we are going to be implement virtualization in all this 1,000 servers or 50 servers. Yes, okay, or if not, so this would be a one server. This logical server is a one server. So we'll be keeping a main server, bare metal servers, 10 servers, and we create the logical servers, 30 servers. We need to maintain, right? Yes, we need to maintain. So this is the virtualization, and maintaining is quite complex and a headache to engineering. And considering all this, one technology came that is containerization. I'm reviewing this. Yeah, containerization. So containerization is going to be done by a Docker. Okay. So, but what is a containerization? Let's talk about. Containerization is nothing but if I have a server, this is a server, and top of this server I'll be having what? Compute server, right? Okay. And top of this I'll going to run my operating system. Linux or Windows, whatever. On top of this, I have to install a runtime of the container. Runtime of the container means we have many options to do the containerization. Okay, we have a many option to do the containerization. Like let's say Docker alternatives. Okay, Docker alternatives tools we have. So we have many tools like Podman, okay, and LXC, and we have even Red Hat OpenShift, and we have Hyper-V. Okay, it is a Hyper-V containers. Okay, and we have yeah, Runc. Okay, so these are all nothing but a Rancher desktop also. So these are all the alternatives of Docker, which is going to help you to do containerization. Okay, to do containerization, and among of this, Docker is in the boom. Docker is having a multiple features which is very easy to configure and deploy and run the containers. So what we do on it, so we can create containerization by using any of this tool, and what we do on it, we are going to install the Docker on top of this operating system. Okay, so this is the Docker. So this is the Docker. So when I'm going with the Docker, so Docker is going to enable a daemon and client on the this system. And here it is enabling me to create the containers on top of the Docker. Now I can go and set up the environments. So these are nothing but containers. So these are nothing but containers. Okay. And these containers are nothing but lightweighted. In previous case, they are not lightweighted. They are heavily weighted. So these are all lightweighted. Okay. So now this container is runs through an image. Okay. Based on the image, it is going to run this container. Okay, on the top of Docker, we are creating the image and we are running this container. Now each container is isolated basically, lightweighted and isolated. How much it is going to take from your server? Hardly 500 MB, 1 GB, 800 MB. That's it. It's not going to take more than that. Okay, so few containers is going to be take more than 1.5 GB also 2 GB also when the load is more on the container, and this container is nothing but again a logical server on your physical server, a logical server on your physical server. Okay, so that is the container. So inside this container my application will run. Inside this container my application I can run. So this is how doing with the Docker, Podman, LXC, Red Hat, OpenShift, okay, and Hypervisor, vContainer, Runc, and Transit Desktop. We have many other tools also. So with this tool, RKT also, and with these tools, we are doing containerization as a service. Now, with this concept, which are the tool are doing a business now, and we are also leveraging them. If you observe, we have a GitHub and GitLab and Azure DevOps, right? GCP DevOps, and we have AWS DevOps, right? So in GitHub and GitLab, now I'll go to my GitHub. For example, I have my GitHub here. Okay, so I have my GitHub here, and I have written one pipeline file here with the GitHub actions. With the GitHub actions, I have written a pipeline here. So this pipeline will say checkout, build, do, Docker image, all these things it will say. Okay, where this pipeline is runs. GitHub is a cloud, right? But where the pipeline is running. So everything, if you want to run something, you need a server. But GitHub, where it is running. So for you, for whenever you create any pipeline, GitHub will give you one hosted runner. So that hosted runner comes from this Docker containerization. Only one of the containers it will pick and assign to you. So this pipeline is going to run on this container. Even your Azure DevOps, also the popular question is Microsoft hosted agent. Where that hosted agent is coming from containerization as a service. One of the container it is going to allocate to you to run your pipeline. Okay, so that is from the containerization service. How it is doing? Okay, by using these technologies. By using these technologies, we are doing this containerization, and we do at infrastructure containerization, and we do at our application containerization. Okay, now I'm just creating this container, nothing but these are also logical virtual missions only. Again, I'm running on top of Ubuntu, again Ubuntu server with a highly advanced configurations. Okay, so I can utilize this one here. So like this, we are utilizing the containerization service in many industries, manywhere. Okay, even we don't know that it is a containerization service, it is utilizing like GitHub and GitLab. Okay, they're running their own runners to run the pipeline from the containerization service only. Okay, containerization is a service. So this is containers, and that is best to do with the Docker. Now let's understand the Docker. So Docker is having the a architecture first thing. Okay, Docker is having an architecture. First, Docker daemon, so when I'm going to run the server, then I'm going to call it as Docker host. Docker host. Okay. So this is my Docker host. So in this Docker host, I'll be having the components, and this is my Docker client. Let me draw a diagram with this Docker client, and this is the registry. Okay, registry. So in the Docker client is a CLI. Okay, so Docker client is a CLI that it communicate with the daemon. So this is my daemon again. Okay, so when you are install the Docker in one server, then you can call it as Docker host. Inside the Docker host, so there will be a daemon or Docker engine. Okay, daemon or a Docker engine will be enabled or will be running inside your host. So what this will be responsible for? So it is responsible for you to run the images and containers. Images and the containers. Docker images and containers. Okay, running the Docker images and containers like this. So these are nothing but containers. Let me write down here. And these are images. Okay. So here, whatever I want to talk with the daemon, I have to communicate through the my client only, like Docker build. Okay. Docker images or pull or Docker run. Okay. This kind of things I have to say through the client itself only. Then my client is going to communicate with my with my daemon, and if the pull and something the image is not there, it is going to pull from the registry and it is going to run inside the server. Okay, so here the container and these things are going to communicate with your daemon, with your daemon it's going to communicate always. Okay, so nothing but we are creating a container from an image only. We are creating a container from an image only. So these images we can pull from the registry. These images we can pull from the registry like Docker Hub. Like Docker Hub. Okay. So Docker Hub, we have a multiple images over there already built up to the Docker, and we can call them here, and the image is nothing but the combination, the collection or the combination, the collection of binaries, libraries and dependencies. Binaries, libraries and dependencies. Okay, so these things I need to run as a container. Inside the container my application will run. So whatever you want to do any operation with this Docker host, okay, so your Docker daemon is going to be do those things. How you will going to instruct your Docker daemon? You have to instruct through the client. So whenever you install in a server, client and daemon both will be enabled, and you have to authenticate with the registry. You have to authenticate with the registry. So this is how the Docker architecture. First thing. Okay, and these are the main key components. So you can create a Docker Hub, type dockerhub.com, and you will get a link. Open that and create sign up. So this will be your Docker Hub. It will be look like this. Okay, it will be look like this. And if I go explore, I'll be having a plenty of the images here. So these are all images. So I can call any of the image. These are all images only. Okay, and to do practice we have a platform called Play with Docker. So type Play with Docker like this and go the first link, and once you have created your GitHub or Docker Hub, here it is going to ask you login. Click on this Docker. So say it as accept. and start. So this is from the Google Cloud itself only, and it is going to give you free server for 4 hours. Okay, so you can do practice for 4 hours. Each instance will give you 4 hours of time. Yep. Now you can see. So here I have to click on add instance. Okay, or you want to go with multi instances also. We have options. Okay, 3 manager and 2 worker nodes, 5 manager and no worker nodes, 1 manager and one worker node. Okay, so let's come to this point also after few classes, and I would like to go with the one session. Now you can see the 4 hours and the countdown is started. And if you click on add new instances, it is going to add an instance with already it comes with the installation of Docker. If I directly type docker info, it shows the Docker. Okay, and now if I let me increase the font. Okay, if I type Docker images, see I don't have any images. Docker ps. Now here we have client also, and we have daemon also here. Okay, so now from the Docker hub I can pull the images and I can run them. Okay, I can pull the images and I can run them. So here we'll start the doing practice from here itself only, and I'll show you other platforms where we can do a free of practice. Okay, thank you guys, thank you very much. Let's meet in like second video.